right, let's take a look at our Chapter 6 vocabulary. There were a lot of words that we probably weren't introduced to for the first time, but taking a look at the characteristics of each of these figures. So the first word we were introduced to was polygon. So we have a visual of it. This is a hexagon. You'll want to go back to Lesson 1 and look at the names of the different polygons based on the number of sides, so make sure you're going back and studying those. But a polygon is a closed figure with segments for sides, so each of the sides needs to intersect, meet at an endpoint with the consecutive side, and there can't be any curves. When we talk about the sides of a polygon, those are the straight segments that meet at endpoints. And so I think this is, what they introduce you to in elementary school when we first start talking about figures and shapes. So this word really wasn't something that we struggled with. The vertex is where the endpoints of two segments meet, and they create the angles of the polygon. So kind of the corners, we would think of those as being our vertex. The diagonal of a polygon, we're going to study some quadrilaterals that have special diagonal properties, but the diagonal is just a segment that connects two non-adjacent vertices, and these are normally found inside the polygon. So then we went and studied a special type of quadrilateral, and that was a parallelogram. So it's a quadrilateral, meaning it has four sides, and some of those properties were both pairs of opposite sides had to be parallels. Remember, parallel is marked with those arrows on the side, so we need to see that on both pairs of opposite sides. Both pairs of opposite sides are congruent, and so if I don't see the parallel symbol, if I see the tick marks that show me opposite sides are congruent, I can also state that it's a parallelogram. Both pairs of opposite angles are congruent, and we know that the diagonals bisect each other. Diagonals aren't congruent, but what it is that on each side of that intersection of those diagonals, we have two congruent segments. A rhombus was the first special parallelogram that we studied, so it still has all the properties of a parallelogram. Opposite sides are parallel, opposite angles are congruent, but what's special about this parallelogram is that it has four congruent sides. So not just having opposite sides that are congruent, but it has all four sides being congruent. And we know that the diagonals are going to be perpendicular, which means they intersect at 90 degrees. For a rectangle, this was our second special parallelogram. So once again, because it's a parallelogram, it has all of those properties that we mentioned with the parallelogram. But what it has is four congruent angles. So we have the 90-degree angles, and it has congruent diagonals. So not only are the two diagonals going to bisect each other, but they're going to create four congruent segments because each diagonal is the same length. And then a square was kind of like the meeting of all characteristics. It was a special parallelogram that has all the properties of a rhombus, so it has four congruent angles, has diagonals that are perpendicular, it has four congruent sides, and it has congruent diagonals. So we need to see not only four 90-degree angles or four congruent angles, depending on how they want to mark those for us, but we also need to be able to see that the sides are all congruent. A trapezoid was a special type of quadrilateral, so we moved away from the parallelograms, and it has only one pair of parallel sides, which is why it can't be included with the parallelograms. And what we know is that because we have two parallel sides is that the consecutive angles along the non-parallel sides are supplements. These are same-side interior angles, and so from early on in the year, we know that same-side interior is supplement. So if we take the two angles that I've marked and we add them together, they're going to equal 180. The bases of a trapezoid are the two parallel sides of the trapezoid. The legs of a trapezoid are the two non-parallel sides of a trapezoid. The base angles of a trapezoid are the two angles along the parallel side. These will not be supplementary. When we look at our next vocabulary word, base angles can be congruent, but base angles are not the supplementary ones. An isosceles trapezoid, similar to what we've seen earlier with isosceles triangles, where the legs are going to be congruent. So we're going to see parallel being marked on the bases, and the two legs are going to be marked as congruent. And what we know is that the base angles, so the two along the bottom on this trapezoid and the two along the top are going to be congruent. It's still going to have the same property of every trapezoid, that the two same side interior angles are going to add up to 180. And your last word, our last vocab word of the chapter, was mid-segment of a trapezoid. The mid-segment is a segment that connects the midpoint of the legs of a trapezoid. And so this mid-segment is running through the middle, in essence, of our trapezoid when we look at that. And so you're going to see congruency marks. The above and below that midpoint are going to be congruent, because that's the definition of a midpoint. We see the same thing over here on the left-hand side. And what we know is that the length of that is the average of your two bases. And so some of us took a look at noticing that it's equidistant from the two bases. And so we have a couple of different ways of finding those measurements. You need to make sure you go back and look at some example problems from the checkpoints, from the examples, from the book, and make sure you're confident finding that mid-segment. Please make sure you're going back and rereading the vocab that we took during the lessons, but this is kind of a nice wrap-up of that before we take our chapter test. Have a good day.